Welcome to JB's Academy of Science. This video series will help you in preparing for NEET and other competitive examinations. Questions from previous examinations are included in this video series. The solutions to the problems are given at the end of the video. And this video series is prepared chapter wise. This chapter is for motion in a straight line. Question number 1. Velocity time curve for a body projected vertically upwards. Option A, straight line. B, parabola. C, ellipse. D, hyperbola. Question number 2. When a ball is thrown vertically up with a velocity v0, it reaches a maximum height h. If one wishes to triple the maximum height, then the ball should be thrown with a velocity option A root 3 v naught, B 3 v naught, C 9 v naught, D 3 by 2 v naught. Question number 3. If a ball is thrown vertically upwards with a speed u, the distance covered during the last t seconds of its ascent. Option A, ut minus half gt square, B, u plus gt into t, C, half gt square, D, ut. Question number 4. A stone is thrown vertically downwards from the top of a tower with a velocity of 10 meter per second, hits the ground with a velocity of 50 meter per second. The height of the tower is given g is equal to 10 meter per second square. Option A 100 meter, option B 120 meters, option C 150 meters, option D 200 meters. Question number 5. Preeti reached the metro station and found that the escalator was not working. She walked up the stationary escalator in time t1. On the other days, if is stationary on the moving escalator, then the escalator takes her up in time t2. The time taken by her to walk up on the moving escalator will be option A t1 plus t2 by 2, option B t1 t2 divided by t2 minus t1, option C t1 t2 divided by t2 plus t1, option D t1 minus t2. Question number 6. Two cars P and Q start from the same point at the same time in a straight line, and their positions are represented by xp is equal to at plus bt square and xq is equal to ft minus t square. At what time do the cars have same velocity? Option number A plus f divided by 2 into b minus 1. Option B, a minus f divided by 1 plus b. Option C, f minus a divided by 2 into 1 plus b. And option D, a plus f divided by 2 into 1 plus b. Question number 7. A stone falls freely under gravity. It covers distances h1, h2 and h3 in the first 5 seconds, next 5 seconds and the next 5 seconds respectively. The relation between h1, h2 and h3 is option A, h2 is equal to 3h1 and h3 is equal to 3h2. B, h1 is equal to h2 is equal to h3. C. H1 is equal to 2H2 is equal to 3H3. D. H1 is equal to H2 by 3 is equal to H3 by 5. Question number 8. Three different objects of masses m1, m2 and m3 are allowed to fall from rest and from the same point O along three different frictionless paths. The speeds of the three objects on reaching the ground will be in the ratio option A m1 is to m2 is to m3, B m1 is to 2m2 is to 3m3, C 1 is to 1 is to 1, D 1 by m1 is to 1 by m2 is to 1 by m3. Question number 9. An object travels first half of the total distance with a constant speed of v1 and the second half of the distance with a speed of v2. The average speed of the object is option A v1 plus v2 divided by 2, B v1 minus v2 divided by 2, C v1 v2 divided by v1 plus v2, D 2v1 v2 divided by v1 plus v2. Question number 10. A body starts from rest, is moving under a constant acceleration up to 20 seconds. If it moves S1 distance in first 10 seconds and S2 distance in the next 10 seconds, then S2 will be equal to option A S1, B 2S1, C 3S1, D 4S1. Solutions to the problems. First one, the velocity time curve will be a straight line. Second, root 3 v naught. We know that v square is equal to u square plus 2as. The final velocity will be 0 after reaching the maximum height. Final velocity will be 0. Therefore, v is equal to 0. h1 for initial velocity v naught, h1 will be v naught square divided by 2g. Now, for tripling the height, let h2 be the height, let v1 be the initial velocity required, then h2 is equal to v1 square divided by 2g. And we know that h2 is equal to 3 times h1. Now find the ratio of h2 and h1. h2 by h1 is equal to 3h1 divided by h. That is v1 square divided by v naught square. That is v1 is equal to root 3 v naught. The third one, half gt square. Distance in the last t seconds of ascent is equal to distance in the first t seconds of the descent. For descent, v naught is equal to 0. S is equal to v naught t plus half gt square. That is v naught t is 0. Half it, this distance s is equal to half gt square. 120 meter. V square is equal to u square plus 2gh. H is equal to 50 square minus 10 square divided by 2 into 10. That is 120 meters. Question number 5. T1, T2 divided by T2 plus T1. The distance is same s. Therefore, V1 during the first time interval, V1 is equal to s by T1. And during the second time interval T2, P2 is equal to s by T2. The total velocity is V1 plus V2. V is equal to V1 plus V2. That is S by T1 plus S by T2. That is S into T1 plus T2 divided by T1 T2. Now if V is the total velocity, then the time taken T is equal to S divided by V. That is S divided by S into T1 plus T2 divided by T1 T2. That is S into T1 T2 divided by S into T1 plus T2. That is T1 T2 divided by T2 plus T1. Sixth one, F minus A divided by 2 into 1 plus B. The equations of position are given. Finding the derivatives of both. Bp is equal to A plus 2bt. Vp is Vq is equal to F minus 2t. And condition is Vp is equal to Vq, the time instant when two velocities are equal. Then A plus 2bt is equal to F minus 2t. Then T is equal to F minus A divided by 2 into 1 plus B. 7. H1 is equal to H2 by 3 is equal to H3 by 5. H1 is equal to half G into 5 square, that is half G into 25. Now, including H1 plus H2 is equal to half G into 10 square. The total time is 5 plus 5 now, 10. Half G into 10 square, that is half G into 100. H2 is equal to half G into 100 minus half G into 25, that is half G into 75. Now the total fall is for 15 seconds. H1 plus H2 plus H3 is equal to half G into 15 square, that is half G into 225. H3 is equal to half G into 125. Now the relation between H1, H2 and H3, it is evident that H2 is 3 times H1, H3 is 5 times H1. Therefore, H1 is equal to H2 by 3 is equal to H3 by 5. 8, 1 is to 1 is to 1. Velocity does not depend on mass. V square is equal to U square plus 2gs. V is equal to root 2gs for U is equal to 0. So it does not depend on the mass of the object. Ninth one. 2 V1 V2 divided by V1 plus V2. T1 is equal to S by V1 and T2 is equal to S by V2. The total time T is equal to T1 plus T2, that is equal to S by V1 plus S by V2, that is S into V1 plus V2 divided by V1 V2. Average speed is equal to total distance divided by total time, that is 2S divided by T, that is 2S into V1 V2 divided by S into V1 plus V2, that is 2 V1 V2 divided by V1 plus V2. 3S1. S1 is equal to half A into 10 square, that is half A into 100. S1 plus S2, the total distance, half A into 20 square, that is half A into 100, 400. Now S2 is half A into 400 minus half A into 100, that is half A into 300, that is 3 by 2 A into 100, that is 3 times S1. Thanks for watching the video. The more practice questions will be uploaded soon. Please watch the videos and subscribe and support us. Thank you.